Hello everyone, good morning to all of you. Today in this presentation, I'm going to explain about our project. Our project is enhancing operational efficiency and environmental compliance through Lean Six Sigma implementation at Canadian Natural Resources. So I would like to introduce my team. Mayur, Harpreet, Hani, Lakshay, and this is me, Nagasai, and I will be explaining their roles briefly in the next slide. So, as myself, I'm a team lead. My job is to lead the team, managing the timelines and ensuring all the deadlines are met. And the next is Lakshay Bharadwaj. His role as SME, which is subject matter experts, provides guidance and collect all the information related to the technical aspects of the project. Mayur Balda, business analyst, he analyzes the business requirements, collection and interpreting the data, and make sure that all the data is related to the business demands of the customers. Harpreet Kaur, she manages the project schedule and coordinates all the project activities in a timely manner. Honey QA specialists ensures quality assurance and make sure that all the outcomes are according to the standards specified by the customers. Project overview. So in this presentation, I will explain you about what is our end product and what is the problem, the method we choose, and the various phases of this method, and analysis and result simulations, and finally our discussion and findings. So the project end result is the Minitab simulation. We have used the Minitab analysis software to predict the corrosion rate based on the two scenarios, that is minimizing the corrosion rate and getting the certain targeted value of the corrosion rate. So we will discuss in the later slides at the end. So a key problem. In a recent study done by AMPP, the study was a corrosion study to find out the corrosion correction cost for the Canadian industries, which they spent on annually. So they found that Canadian industries spend nearly 63 billion Canadian dollars for correction of the corrosion failures. This is a huge significant amount because it's nearly equivalent to 2.9% of the Canada's GDP. So as a quality engineers, we are mainly focused on providing recommendations to maintaining the corrosion, and which will help the companies to reduce the financial impact by following these recommendations. Now I will just give a short introduction about the CNRL. So it's mainly located in Alberta. Is the largest oil and gas industries in the Northern America, which have it's based in operating various sectors like oil, sand, light and heavy crude oil, natural gas, and synthetic oil production. Well, project focus scope. Particularly, we are focusing on under deposit corrosion, which is the type of internal corrosion within the oil and gas pipelines. The reason why we selected under deposit corrosions, particularly to internal corrosion, will be explained in the later stages of the methodology we have selected in this project. Outcome. So, providing recommendations to improve the pipeline integrity and extending the operational lifespan of the pipeline with the use of mitigation strategies, predictive maintenance, and inline inspections. A business value. After implementing the recommendations, below are the business values, operational efficiency. Companies can increase their operational efficiency by reducing the downtime, by following our recommendations, and in the risk management, we have anticipated the certain risks and gave the techniques and recommendations to predict the risks before they happen so that they can do the risk management part really good. And cost efficiency, by preventing the corrosion related failures, it repair and reduces the repair costs, emergency costs, by following our mitigation strategies. Sustainability and environmental complex. So, as our project recommendations are to reduce the internal corrosion, that means the companies can reduce a significant waste, which is a byproduct of the internal corrosion, and they are compliance with the environmental and sustainability standards. Why Six Sigma? We choose Six Sigma because it's the method which is driven by facts and information, and this method allows to identify the failures, corrosion trends, and root causes, and giving the recommendations to improve the lifespan, reliability, and suggest the best recommendation strategies to mitigate the corrosion. So all this method will serve a company for making a most informed decision. Define phase. The project aims to provide the recommendations regarding the internal corrosion with the help of predictive maintenance. So, as discussed earlier, this focuses mainly on the root cause detection, correcting those root causes, which will have the benefits discussed. And the key matrices identified are corrosion rate, frequency of the pipeline failures, inspection intervals. So, finally, by following these recommendations, CNRL would be able to improve their operational efficiency and reduce the waste. Process map. So the process map involves a process from start to end. For the gas pipeline installation, it will have mainly we are focusing on the scheduled maintenance and inspection part, which is the highlighted area. Measure phase. In the measure phase, we have collected all the categorical data related to the various causes for the pipeline failure. So for over a 12-hour period, we have used the tool pie chart to visually represent these values. From the pie chart, we can see that the internal corrosion is the main part, having the 55% of the contribution. So, analyze phase. In the analyze phase, we have used a tool which is failure mode and effect analysis. So, basically, in this tool, we will list all the failures of the internal corrosion. uh, we will scope it down to one failure based on the RPN number, which is risk priority number. Basically, we have to prioritize this cause, that is prevention of under deposit corrosion, because it have higher RPN number, the more effect it will have. So we need to correct that cause immediately and analyze it. Analyze it. In the analyze phase, we have used the fishbone tool. And in the fishbone tool, we have listed out the seven causes: material, man, method, mother, nature, management, and machine. And out of these four sub causes, we have selected four causes which will be analyzed further. The four causes we have selected are improper welding, improper cleaning, and irregular storage and gas liquid interactions. So all the numerical data backing up why we selected these four causes were listed very detailed in the report, which you can see on our website and access. So basically, we have done effect and impact analysis of these four factors selected. As you can see from this picture, the flow rate and welding are having the highest impact. So we have selected these two factors having the highest impact, and we will take it on from there. So in the improve phase, we are improving the selected two factors, that is flow rate and welding. So we can improve the flow rate by usage of corrosion inhibitors, modeling techniques like CFD, pigging operation, use of internal corrosion coatings like epoxy. So all this data is mentioned again in the report. If you want to have a detailed look, you can refer our report. Flow rate. We should mention monitoring and controlling of the flow rate, proper design and alignment, proper temperature control, cathodic production, and regular monitoring of the velocity. So welding. Basically, in the welding, we have listed all the details like choosing the best method, achieving the lowest corrosion rate by optimization of welding parameters, chemical cleaning, upgrade to corrosion resistant alloy, and post metal treatment, and all the details and all how we did this and were presented in the report. Flow rate, the main culprit is the flow rate, because it's why the flow rate is we have selected better control and monitoring. Flow rate can have better control and monitoring. Its associated cost is much lower than the other methods. So its impact is very severe, and if we correct that, that will have the immediate results we can see. For example, sediment deposition and erosion corrosion. Feasibility and scalability, because controlling, adjusting, and optimizing are comparatively easy. Because in the welding, it will have complex processes like selecting the method, investing for the repairs, and getting a qualified team. And even we do the welding correction by robotic, it will not have that much significant effort compared to the flow rate. Control plan. Basically, in the control plan, it will have all the processes from the starting to ending of the pipeline operations, and we have included the elaborated and detailed control plan in our report. Key findings. Now, I will show the uh, Minitab live simulation. You can see we have selected all the data related to temperature, pressure, flow rate, and pH, and for all the four, the recorded corrosion rate we have mentioned. So in this Minitab simulation, what we are going to do is to find the relation for the corrosion rate in terms of these four factors, and we have performed the regression analysis. So this is the equation for the corrosion rate in terms of these four factors and the model summary. So as you can see, 95.01% means it describes that much accurately how corrosion rate is related to these four factors in terms of this equation. Next, we have selected the DOE experiment maximum and minimum. Maximum and minimum. We have specified the lowest levels for each of these four factors, which you can take a look here. Uh, and we have mentioned all the details in the report also. So after performing the DOE, this is the result section. The mainly our focus part is this graph. This graph showing that these factors A and C, which is temperature and flow rate, is crossing the red line. That means these two have the most. These two factors have the most effect on the response variable, which is the corrosion rate. Now, response optimization. So in this response optimization, firstly we will discuss two categories. So first is getting the certain targeted value of the corrosion rate. So we selected the targeted value 3.98 with having the lower and upper limits as mentioned in this table. So after doing this responsible optimization simulation, we got this graph. So basically in this graph we can see if you change the values, so automatically the corrosion rate changes. So basically the companies can make use of this model to get the certain value of the corrosion rate by changing any of the four factors. And next is minimizing the corrosion rate. So to minimize the corrosion rate, which is the another optimization we did. So basically in this interactive mode, you can see that at these settings 100 degrees centigrade, 360 uh, pressure and flow rate and pH, at these four settings the corrosion rate is minimum 3.98. So companies can use the values of these four settings to minimize the corrosion rate. And going back to our presentation, this is the key findings from the analysis we done. A lower flow rate causes the sedimentation, and higher flow rate increases the erosion. So we need to find an optimal value. So temperature increases the corrosion rate. Poor welding causes the uneven surfaces, and so basically, as all these four factors have drawbacks, so we need to find certain optimal value, we need to find optimal value, which I showed in the mini tab section. So this is basically the results I showed in the mini tab. So we have used the design of experiments. This is the regression equation I have just showed in the mini tab. And this is the effects. As I'm explaining again, A and C temperature and flow rate have the most significant effect on the response variable corrosion. Achieving the corrosion rate, as I said, we need to get the minimum corrosion rate. If the conditions doesn't follow, we provide the targeted corrosion rate. So at these values, the corrosion rate is minimized as I showed in the Minitab simulation. So targeted corrosion rate, so we can get any certain targeted value by specifying the lower and upper limit, certain things. So discussions. So key findings. So key findings. improper flow rate, we have used the CFD model to optimize, and the impact it have, it improved the pipeline lifespan. And welding 120 amperes and 18 amperes GTAW technique reduce the corrosion risks. And for the real time monitoring, we have used the sensors to track the four factors, so which can minimize the downtime. Proactive maintenance and can lead to further detection of defects. So, waste and energy management. We have used the intelligent cathodic production and epoxy lining to reduce the waste, which will improve the sustainability and reduce the operation cost. Inspection. So, we have implemented the pigging schedules and corrosion inhibitors. So, we have used FMEA, which can improve the risk management. So, these are the key metrics I discussed. To summarize for you and conclusion. So, basically, with this project, the recommendations with the Six Sigma can study the effect of the under deposit corrosion rate and their maintenance and mitigation strategies. So we demonstrated the advanced technologies and tools we use it to mitigate UDC risks and data-driven methodologies to extract the significant useful information. So finally, to wrap up, the project achieved its significant objectives by reducing corrosion rate, improve optimization confidence, and ensuring compliance. Now, if you are looking to meet our team more in person and want to know more details or have any questions, you can visit our website. So I will show the website of ours. So this is the home page, and it have all the information. Our the project client is Canada Natural Resources. So this is the data, and if you have any questions, you can fill the form, and now one of our team will get back to you, and you can see the uh, related to our project. We have project files also here. This is the project files, our report, and PPT and marketing video. And if you want to meet us in person and meet with our team to discuss any queries you have or experience the live simulation, you can visit our team on December 10th. We will be there in the recreation room from 9:30 a.m. to 12:30 p.m. These are the references we use, uh, and it presents our the research depth of research we have done. If you have any questions, please let us know. Thank you.